Packet 2, kinematics 1D in 1 dimension, the multiple choice is part of it. So in here, I will try to show you every single step that I took in order to answer those questions. Because the multiple choices, like I asked you, yes, you can just circle the answer, but what I am looking for is the way you actually are able to reach that particular answer. So, this is the first question of your packet. So, in the absence of a resistance, a ball dropped near the surface of the Earth experiences a constant acceleration of. Now, what this question is looking for is really truly understanding of the meaning of those units. Remember when I said units will guide you all the time. So this stuff, right, this number is 9.8. The unit, though, okay, means meter per second divided by second. Before you dive into this, actually, maybe it's better if we go once more into the math behind this. So when you have a number, let's say 5, right, and you're dividing this number by something that looks like this, okay, remember the meaning of this stuff. How many different ways you can solve something like that? Well, you can say, right, so this is the same as, so the solution 1, let's say, you can do a 5 divided by 2 times 7, which is what everybody usually does, right? So you do 5 divided by 14, and then whatever number you have, you put it right there. But you can also do a 5 divided by 2, find this number, whatever it is, and then you take this number, right? So basically you're using this portion, right? So you're doing 5 divided by 2, and then whatever number you have, you divide it by 7. And you will have, hopefully, unless you made a mistake with your calculator, you will have exactly the same number. For example, 5 divided by a straight 14, this is the 0.36 if we round up, which we should, right? In this case, instead, 5 divided by 2, you know, is a 2.5, right? And then you take 2.5 and you divide this number by 7. Duh, you still have a 0.36. Or you can also do a 5 divided by 7, right? So you take this portion here instead, right? And then, so you solve this, and then whatever number you have, you divide it by 2. Now, in this case, 5 divided by 7 is 0.71, okay? Which, again, if you divide by 2, will be 0.36, right? Or you can do what I usually ask you to, is 5 divided by 2 and divide this one by 7. Now, why are those two things the same? Well, you have a 5 divided by 2, right? And you're dividing this by 7, which means 5 divided by 2, and you're multiplying by the inverse, which is still 5 divided by 14, right? So this 5 divided by 2 and divided by 7 is still the same number, 0.36, right? Now, how is this important? Well, if 5 is, let's say that we have 5 is related to meters, right? The 2 is the first second, right? And 7 is also second, right? Basically, by putting all those stuff together, you have a meters per second, right? Which will be the 5 over 2, right? This one will be the same as 5 over 2. And then you're dividing by second, right? Which in this case is 1 divided by 7, right? So, meters per second divided by second, okay, will give you meters per second squared, because you're multiplying the second. You're multiplying the second with the second, just like you did the 2 and the 7. And you had the 14 there. So, again, why is this important? So, let's go back to your packet. And they are saying 9 meters per second squared. This means just by looking at your unit means meters per second, right? So would be straightforward the answer A, because it's the speed of an object, which is meters per second, during each second, which means per second. We'll give you the meters per second per second. So meters per second squared. Okay. The rest doesn't make sense. Speed of an object falls at, this is meter per second, this is meters per second squared. The object falls 99.8 meters per second. This is not the meaning of this, and plus is not true. Object falls 9.8 meters during the first second only, doesn't mean anything. This is constantly. And then derivative of distance with respect to time, derivative of distance with respect to time is your velocity, is not the acceleration. So your answer, okay, is A. So as you see, there is a long explanation, right, for this first question. Question number 2. You have a 1,000 kilogram truck accelerates uniformly from rest, reaching a speed of 50 meters per second in 10 seconds. During the 10 seconds, the truck has traveled a distance of. Writing down 50 meters per second times 10 seconds, just because you're doing maybe dimensional analysis, or you're just using your units, that will give you 500 meters, which is now one of your choices, so obviously it's wrong. What's the reason for this? Well, go back and read carefully. They say the truck accelerates uniformly from rest. So this means that your truck is going from a velocity v0 equal to 0 meters per second to a velocity, right, at time 10 of 50 meters per second. So by doing so, you cannot just use this equation, because this one will not take into consideration the fact that you actually have acceleration going on there. So your equation instead is going to be the one that you remember from class, y equal y0 plus v0 t minus 1/2 a, or plus 1/2 a t squared. So by doing so, you have initial velocity is 0. Your displacement in total, right, is the 50 meters. This is 0 at that point. So you have 1/2 a t squared. And from here, you know that your time is 10 seconds, but you have no information straightforward for the acceleration. So this means you have to go through the acceleration process first. You know that acceleration is the change in velocity per time. So velocity changed from 0 to 50, so you have a 50 meters per second velocity, change in velocity in 10 seconds, right? So this is going to be your 5 meters per second squared, so that will be your acceleration, which you can go and plug in there. So, I'm sorry, I don't know why I moved this. This is just y. And then, at that point, the y, that is the question that they are asking, is going to be 1/2 times the 5 times the 10 squared. So it's going to be your 5 divided by 2, 2.5 times 100, and that would give you the 250 meters, which is your question, your choice D. Question number 3. Velocity as a function of time of a moving object is represented from here, in here. The object moves in one dimension, and at time t equals 0 is 0, b is 0 is 0. Which of the following graph best represents the displacement as a function of time? So let's see what this graph actually means first of all. So here, right, you have we said this is velocity. So the body is moving at a constant velocity, is negative or toward the negative direction, right? But it is traveling. So this graph here means that the object is stationary as a space, right? Because it's moving at no space at all. And so this one removes choice A, and choice C also, because this is also 0. So you have more choices. So the velocity is increasing, the velocity is stationary, so the body is moving at a constant velocity in the negative direction. So this instead is the positive direction, right? So cannot be it. So your choices can only be D or E. So let's see which one of those two. This is just to go, by multiple choice solution without thinking too hard, I should say, but it's not a preferred one by me, but still this is something you can go by. So once you have traveled some kind of velocity, okay, so you are moving, okay, in a negative direction, because you're moving, let's say, if we go along by this, right, and positive, for example, is east, so you're moving west. So this is basically what you're doing, okay? And you remember the velocity, okay, constant means basically v equal, let's say, -5. And if this is x equal to v equal to -5, then your x, right, is the integral of this. So is the integral of dt. So you got to have a function which looks like -5t. So it has to be a line, right, with a negative slope. So it has to be a first order curve, right? So it has to be either this or this. Then keep looking, okay? So here velocity increases. Now, if this is a straight line, right? So for example, this, and you got to integrate this. So you have a -5t, and you got to integrate this dt, right? This one becomes a -5 over 2t squared. So it has to look like a parabola. So this one looks like it's a part of parabola. This is a straight line, right? So it cannot be, especially because if your velocity is increasing, right, then your space, right, the distance traveled is also increasing, right? But since it's going to change from the east to the west direction, obviously you got to also show that you have a concavity of 0, right, where the velocity goes to 0 and then changes again and becomes positive, right? So once it becomes positive, then this graph says, well, this point stays stationary, so from here on it's just a stationary line again. So D is your answer. And I'll stop here, so the second part will be the next video, okay?